Hello everybody, this is Miss Guo, and here is my online video review for all things biochemistry. Okay, so as a reminder of all things biochemistry, in biology, the biggest and most important concept or most important molecule that you'll find in biology is water. So that is where we are going to start off. The reason why that whenever scientists look for life in another planet, we typically look for signs of water, for example, in our solar system, because it is one of the most important molecules that can exist to help support life. So water gives you life. So let's take a look at water. Most of you know that water is H2O, meaning it has two hydrogens, and one oxygen. So these two, in case you weren't already familiar, these two are two of just many elements that are composed, that exist on this earth that helps us to build all of the matter, all of the stuff that exists on earth. So this two, don't get confused, goes with the hydrogen, not with the O. So you have two hydrogen and one water. So this water molecule, when you put these two hydrogens and oxygens together, you're going to get something that looks like this. Your oxygen is going to be on in the middle, surrounded by your two hydrogen atoms right there. Now this right here in between is a covalent bond. A bond is just a chemical joining, these two atoms are chemically joined together. So this oxygen is joined chemically to this hydrogen in a covalent bond. Both of these are covalent bonds that you have to know. Now, the other bond that we talk about is actually not a real bond. Whenever we say bond, we say it's a join. We are connecting them. However, when you have another molecule that is just hanging around, being nearby, sometimes they can interact with them. So this interaction that we have here is your hydrogen bond, but it's more of an interaction than an actual bond. Interaction right there. Okay, now you're going to have to know how to draw these things, and you're going to have to know why that this bond, this hydrogen bond, this interaction can actually occur. This is because your oxygen is going to be a little bit negative, and this is because your hydrogen is a little bit positive. Now, this is because whenever you are joining two atoms, this is because you are sharing electrons. Sharing electrons allow you to chemically join together. Now, electrons are just a part of your whole atom that is a negatively charged portion, negatively charged. So it's going to be represented by a minus. Now, if your oxygen and your hydrogen share your electrons evenly, if your electrons are here evenly, let's say this is O and this is H, and your electrons are shared evenly, this is my electrons right here, electrons here. If they are evenly shared, then that means that the electrons are not anywhere close to, any further closer to oxygen than they are to hydrogen. When they're in the middle, these two do not have a positive or negative. However, if the oxygen and the hydrogen do not share them equally, so this is now an uneven sharing of electrons, then this means that the electrons here are closer to the oxygen than they are to the hydrogen. Because these are actually negative, having the electrons, the negative electrons, closer to oxygen, meaning oxygen is now going to be negative. And because your hydrogens are away from your electrons, they're going to be slightly positive. So we don't actually want to do this. In water, they are not equally shared. In other molecules, they may be equally shared, but in water, they are not equally shared. Now, whenever this is unevenly shared, we call this polar. We call this polar. We say that water is polar. Water is polar because you have uneven sharing, because the electrons are not directly in between my oxygen and hydrogen. Now, because it is polar, because you do have a positive and negative, that allows your negatively charged oxygen here, which I'm going to represent with yellow, to interact with your positively charged hydrogen, which I'm going to represent here in blue. Your first underlying fundamental concept here is that your opposite charges are going to attract. So opposite charges, so like positive and negative are opposites. So opposite charges are going to attract. And this is what causes your H bond interaction. So because opposite charges attract, this positive on the H is going to interact with the negative on the oxygen. Okay, so if I ask you to show me water and how it looks, you are going to give me something that looks like this. You have to label for me the partial charges. So is it positive or is it negative? Is it positive or is it negative? And you're going to have to show me the interaction between two water molecules. So when you do this, draw me two water molecules, label both of them. Label both of the charges. Is it positive, is it negative? And you have to, 100% must, put the parentheses, put these parentheses around them. Then you can label your bonds. So your covalent bond, again, is the solid line. And then you're going to have to show me an interaction. So the interaction between these, again, revolves around how opposite charges are attracting. So that means you look at your positive, you look for a negative, and that is your positive to negative interaction called your hydrogen bond, even though it is not a real bond. Okay, that concludes the first part about why water is polar, the structure of water. Structure of water.